Good day, geniuses. Welcome once again to Mapima with Mr. Smith. And today we're going to be looking at a very special topic, this titled a number base. Now, very quickly, what is a number base? For my definition here, we have that a number base is a combination of several digits used by a system of counting to represent numbers. Now, while we know that there are several systems of representing numbers, which include systems like the Greek numerical system, the Arabic numerical system, the Roman numeral system, the Babylonian numeral system, the Hebrew numeral system, and the Tali numeral system. All these systems exist, but today we are looking at the number-based system. Very quickly, for the sake of this topic, today I'll just be covering addition and subtraction of numbers in base 2. Now we know that in number-based system there are about 3 special bases, which include number base 2, which is also known as binary numbers, number base 10, which is also known as ternary numbers, and others. When I talk about others, that includes both base 3, base 4, base 5, and the list goes on. So we're going to be looking at addition and subtraction, including multiplication of numbers in base 2. Are you ready? Then let's go. Okay, so we have our examples right here. The first question says simplify 112 plus 101 in base 2 as well. And then number 2 says simplify 1001 in base 2 minus 111 in base 2. While the third one says simplify 110 in base 2 multiplied by 111 in base 2. So for the first one, we're going to be solving. The first one, now it is important we note that in binary system of numbers, you must take note of these following keys. The first note is that in binary, 1 plus 1 is equal to 10. 1 plus 1 is equal to 10. That's our first note. While the second note, as we come into this topic, is that 10 minus 1 is equal to 1. 10 minus 1 is equal to 1. Now with this understanding, let's come to this. Now we have 1, 1, 1 in base 2 plus 1, 0, 1 in base 2 as well. In base 2, they are both in base 2. So we want to add this according to our notes. 1 plus 1 is 10. I know you learned it as 2, but here in binary system of numbers, it is different. So we must take note of that. 1 plus 1 is what? 10. So write 0 and carry 1 up there as usual. Then we go 1 plus 1 plus 0. 1 plus 1 is 10. 10 plus 0, 10. So write 0 and we'll put 1 right up there. Then we have 1 plus 1, 10. 10 plus 1, 11. So our final answer is equal to 1100 in base 2. This is our final answer. We'll come to the next question. The next question says 1001 in base 2 subtract 111 in base 2 as well. So when we have our numbers written like this, and then we start. So we have 1 minus 1. 1 minus 1 is 0. 0 minus 1. We know that mathematically that is not possible. So what do? We are meant to come here and borrow 1 from 10. Borrow 1 from 10. And when we borrow 1 from 10, 10 is left with 1. We'll put that 1 here. It becomes 10. 10 minus 1, according to our note here, says 1. And then 1 minus 1 is 0. We can decide to leave it the way it is in base 2. Our answer here is 10 base 2. 10 base 2. While for our last question here, we have 110 in base 2 multiplied by 111 in base 2 as well. To multiply this, we start with the first very last digit at the tail end. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. We go to the next digit after the first multiplier. We go to the second multiplier. It gives us 1 times 0, 0. We don't put it here, we put it after the second digit. 1 times 1, 1, and 1 times 1, 1. I will come to the third multiplier. There are 3 multipliers. It's a 3 by 3 multiplication question. We'll say 1 times 0. The next 0, you're not going to put it here as well. You're going to leave that first space, just like you did here. Leave this space, you put it here. 0, 1 times 1, 1, 1 times 1, 1. At the end, we're going to add up everything we have here. If we do that, then we're going to have 0 plus nothing gives you 0. 1 plus 0 gives you 1. 1 plus 1, according to our notes, here says 10. You write 0, you carry 1. 1 plus 1 is 10. 10 plus 1 gives us 11. You write 1, you put 1 up here. 1 plus 1 gives us 10. You put it up here. The way it is. 1, 2, 3. Come on. This is 1,010 in base 2. So our answer is 101. And in base 2. So I hope you enjoyed the class. In my next class, I'm going to be dealing on conversion of bases, and I'm going to be leaving you with some exercise with which you can practice with. Catch you in the next class. Okay, so here we have some questions, some brain teasers with which you can exercise and then get to flex yourself with this topic. So we have 1, 0, 0, 1 in base 2 plus 1, 1, 1 in base 2. We have 1,000 in base 2 plus 11 in base 2. We have 1, 1, 1 in base 2 multiplied by 1, 1, 1 in base 2. So as you solve these questions, you must take notes. The notes here are 1 plus 1 is 10. 10 minus 1 is 1. And 11 plus 1 is 100. So when you solve it, you can send it to me.